Hello guys. How are you? Hope you doing fine. Thanks for always checking my YouTube channel. I love you. If it your first time here, kindly hit the subscribe button and subscribe to my channel, like my videos, on your alarm bell and don't forget to drop your comment below. If you have done that, thanks. I really appreciate it. Now, let's jump to today's business. Dear student, you are starting to learn about computation and its purpose. This course covers the same materials as an introductory class for undergraduate computer science majors. Its curriculum, which includes software, hardware, and algorithms, resembles that of a 1 or 2 semester first-year college course or the high school advanced placement, AP, computer science. It does not require a formal computer science background. There is also a gentler introduction to computers for non-majors, and a basic course focusing on programming that is taught in several computer languages. The rewards of taking this course are immense. In addition to being a subject in itself, computer science can be applied to almost any other discipline from accounting to zoology. The job prospects for computer scientists and computer engineers are excellent. Be patient in your studies, and don't get too frustrated if you are stuck on one part of a programming assignment or confused about a concept. Struggling with the materials is a normal and essential part of the learning process. You're probably better off going through the course sequentially and consulting external references as needed. Each lesson, particularly in the programming component of the course, builds on previous sections and it is best to keep up with the materials throughout. You're welcome to go at your own pace and begin or end at any time. Aims and objectives of the course. The aims and objectives of this course include the following. 1. To understand fundamentally the general scope of the computer system. 2. To interact effectively with the computer. 3. To know the uses of the basic components of the computer. 4. To manage the system to some extent before involving an expert. 5. To know some basic things about the computer and the world. Introduction. Computer as a revolution left no area of life untouched in the present world. It is of tremendous help in all field of life. Hence, the knowledge of computer is a necessity for existence of everybody in this global village. The invention of computer has transformed our simple manual works to sophisticated life of automated works to meet the global demand for the higher productivity and increased efficiency with high precision. Computer is increasingly becoming compulsory in nearly all fields of studies, not because of anything, but its accuracy and versatility in processing data. Many tasks at home or office are being automated rapidly with computer. Thus it is becoming apparent that in whatever discipline or working sector, the computer is now a very vital tool for efficiency improvement and precision of job or task execution. Generations of computers. The history of computer development is often referred to in reference to the different generations of computing devices. Each generation of computer is characterized by a major technological development that fundamentally changed the way computers operate, resulting in increasingly smaller, cheaper, more powerful, efficient and reliable devices. First generation, 1940 to 1956, vacuum tubes. The first computers used vacuum tubes for circuitry and magnetic drums for memory, and were often enormous, taking up entire rooms. They were very expensive to operate, and in addition to using a great deal of electricity, generated a lot of heat, which was often the cause of malfunctions. First-generation computers relied on machine language to perform operations, and they could only solve one problem at a time. Input was based on punched cards and paper tape, and output was displayed on printouts. The UNIVAC and ENIAC computers are examples of first-generation computing devices. The UNIVAC was the first commercial computer delivered to a business client. It was used in the 1951 U.S. Bureau census. Second generation, 1956 to 1963, transistors. Transistors replaced vacuum tubes and ushered in the second generation of computers. The transistor was invented in 1947 but did not see widespread use in computers until the late 50s. The transistor was a vast improvement over the vacuum tube, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable than their first-generation predecessors. Second-generation computers still relied on punched cards for input and printouts for output. Second-generation computers moved from cryptic binary machine language to symbolic, or assembly, languages, which allowed programmers to specify instructions in words. High-level programming languages were also being developed at this time, such as early versions of COBOL and Fortran. These were also the first computers that stored their instructions in their memory, which moved from a magnetic drum to magnetic core technology. The first computers of this generation were developed for the atomic energy industry. Third generation, 1964 to 1971, integrated circuits. The development of the integrated circuit was the hallmark of the third generation of computers. Transistors were miniaturized and placed on silicon chips, called semiconductors, which drastically increased the speed and efficiency of computers. Instead of punched cards and printouts, users interacted with third-generation computers through keyboards and monitors and interfaced with an operating system, which allowed the device to run many different applications at one time with a central program that monitored the memory. Computers for the first time became accessible to a mass audience because they were smaller and cheaper than their predecessors. Fourth generation, 1971 present microprocessors. The microprocessor brought the fourth generation of computers, as thousands of integrated circuits were 3/59ths, NOV, 2010. Built onto a single silicon chip. What in the first generation filled an entire room could now fit in the palm of the hand. In 1981 IBM introduced its first computer for the home user, and in 1984 Apple introduced the Macintosh. Microprocessors also moved out of the realm of desktop computers and into many areas of life as more and more everyday products began to use microprocessors. As these small computers became more powerful, they could be linked together to form networks, which eventually led to the development of the Internet. Fourth-generation computers also saw the development of GUIs, the mouse, and handheld devices. Fifth generation, present and beyond, artificial intelligence. Fifth-generation computing devices, based on artificial intelligence, are still in development, though. There are some applications, such as voice recognition, that are being used today. The use of parallel processing and superconductors is helping to make artificial intelligence a reality. Quantum computation and molecular and nanotechnology will radically change the face of computers in years to come. The goal of fifth generation computing is to develop devices that respond to natural language input and are capable of learning and self-organization. What is hardware, and give examples? Hardware refers to the physical elements of a computer. This is also sometimes called the machinery or the equipment of the computer. Examples of hardware in a computer are the keyboard, the monitor, the mouse, and the central processing unit. What are the 8 types of hardware? Hardware: monitor, motherboard, CPU, microprocessor, main memory, RAM, expansion cards, power supply unit, optical disk drive, hard disk drive, HDD. What is software and example? Software is the programs and routines for a computer or the program material for an electronic device which make it run. An example of software is Excel or Windows or iTunes. Software and its types. Computer software and its types. Application software, general purpose, word processing, graphic and multimedia software. System software, operating system and its functions, language processor, utility software. Special purpose application software. Disk size conversion chart, bits, bytes, kilobytes, megabytes, and gigabytes. Bit, binary digit, a single elements in the computer memory that can store either 1 or 0. Word, 1 byte, 2 byte, or 4 byte depending on the machine. Generally computer word length is given in bits. Hence we have 8-bit, 18-bit, or 32-bit microprocessor computer. Table 1, Computer Storage Devices Unit Conversion. Unit equivalent to 1 byte, 8 bits. 1 kilobyte, KB, 1,024 byte. 1 megabyte, 1,024 KB equals 1,024,000 byte. 1 GB, 1024 megabytes equals 1,024,000,000 byte. Types of computers. Analog computer. These systems were the first type to be produced. It is an electronic machine capable of performing arithmetic functions on numbers which are represented by some physical quantities such as temperature, pressure, voltage, etc. Analog refers to circuits or numerical values that have a continuous range. Popular analog computer used in the 20th century was the slide rule. Digital computers. Virtually all modern computers are digital. Digital refers to the processes in computers that manipulate binary numbers, zeros or ones, which represent switches that are turned on or off by electrical current. A bit can have the value 0 or the value 1, but nothing in between 0 and 1. A desk lamp can serve as an example of the difference between analog and digital. If the lamp has a simple on/off switch, then the lamp system is digital. Because the lamp either produces light at a given moment or it does not. If a dimmer replaces the on/off switch, then the lamp is digital, because the amount of light can vary continuously from on to off and all intensities in between. Digital computers are more common in use and it will be our focus of discussion. Hybrid computer. This is when a computer make is of both analog and digital components and techniques. Such computer require analog to digital and digital to analog converter which will make analog and digital data palatable to it. The basic classification nowadays uses the following. The desktop. A computer is referred to as desktop when it is relatively small enough to be positioned on top of a table where a person is working. Such a computer can also be placed on the floor or somewhere under, or aside of, the table, in which case the monitor would be placed on top of the table. This is the most common type of computers used in the office or at home. A desktop computer is made of different parts that are connected with cables. 2. The laptop. A computer is called laptop when it combines the CPU, the monitor, the keyboard, and the mouse in one unit to be so small that you can carry it on your laps when traveling or commuting. A laptop is also called a notebook. Other parts, such as an external mouse, an external keyboard, or peripherals such as a printer or a projector, can be connected to the laptop. A laptop is only physically smaller than a desktop but, everything considered, it can do anything that a desktop can do. 3. The server. A server is a computer that holds information that other computers, called workstations, can retrieve. Such workstations are connected to the server using various means. This means that they could be connected using cable, wireless connection, etc. Only computers that maintain a type of connection with the server can get the information that is stored in the server. Normally, although not particularly recommended, any computer, including a desktop or even a laptop, can be used as a server, as long as it can do the job required. A server is more defined by the program, called an operating system, that is installed in it, not how the machine looks. Any type of computer, including a desktop, a laptop, a CD or DVD machine, etc., can be connected to a server. The person who sets up a server also defines the types of connections it is made for. 4. The mainframe. A mainframe is a computer, usually physically big, that does almost all the jobs for other types of computers that are connected to it. This is a broad definition, but other aspects are involved. Like a server, the program, operating system, that runs in the mainframe defines its role. Computer hardware. Hardware system. Computer hardware consists of the components that can be physically handled. It refers to the physical units or machine of functional units, which makes up the computer configuration, which is done to suit the goals and objectives of the user. The function of these components is typically divided into 3 main categories: input, output, and storage. Components in these categories connect to microprocessors. Specifically, the computer's central processing unit, CPU, the electronic circuitry that provides the computational ability and control of the computer via wires or circuitry called a bus. Hardware may be classified into central processing units, CPU, and the peripherals. The CPU entails control unit, CU, arithmetic and logic unit, ALU, and the internal memory unit, IMU, or main memory. The peripherals consist of the input, output, and auxiliary storage units. Strictly speaking, computer is made up of 5 distinct elements to include 1. A central processing unit, ALU and CU. 2. Input unit. 3. Output unit. 4. Storage unit, internal and auxiliary. 5. The communication network, business that links all the elements of the system, and connects the 6. External world. Cables and cords. What is input and output device? An input is data that a computer receives. An output is data that a computer sends. Computers only work with digital information. An input device is something you connect to a computer that sends information into the computer. An output device is something you connect to a computer that has information sent to it. What are the 8 input devices? 8 examples of input devices: keyboard, mouse, touchpad, scanner, digital camera, microphone, joystick, graphic tablet. Examples of 8 output devices: monitor, printer, headphones, computer speakers, projector, GPS, sound card, video card. How computers store data. Concept: all data that is stored in a computer is converted to sequences of zeros and ones. A computer's memory is divided into tiny storage locations known as bytes. 1 byte is only enough memory to store a letter of the alphabet or a small number. In order to do anything meaningful, a computer has to have lots of bytes. Most computers today have millions, or even billions, of bytes of memory. Each byte is divided into 8 smaller storage locations known as bits. The term bit stands For binary digit, computer scientists usually think of bits as tiny switches that can be either on or off. Bits aren't actual switches, however, at least not in the conventional sense. In most computer systems, bits are tiny electrical components that can hold either a positive or a negative charge. Computer scientists think of a positive charge as a switch in the on position, and a negative charge as a switch in the off position. Storing numbers. A bit can be used in a very limited way to represent numbers. Depending on whether the bit is turned on or off, it can represent one of two different values. In computer systems, a bit that is turned off represents the number 0 and a bit that is turned on represents the number 1. This corresponds perfectly to the binary numbering system. In the binary numbering system, or binary, as it is usually called, all numeric values are written as sequences of zeros and ones. Here is an example of a number that is written in binary. 100111101. The position of each digit in a binary number has a value assigned to it. In case you are curious, the ASCII code for uppercase B is 66, for uppercase C is 67, and so forth. Appendix C shows all of the ASCII codes and the characters they represent. The ASCII character set was developed in the early 1960s, and was eventually adopted by most all computer manufacturers. ASCII is limited, however, because it defines codes for only 128 characters. To remedy this, the Unicode character set was developed in the early 1990s. Unicode is an extensive encoding scheme that is compatible with ASCII, but can also represent characters for many of the languages in the world. Today, Unicode is quickly becoming the standard character set used in the computer industry. From machine language to assembly language, computers can only execute programs that are written in machine language. As previously mentioned, a program can have thousands or even millions of binary instructions, and writing such a program would be very tedious and time-consuming. Programming in machine language would also be very difficult because putting a 0 or a 1 in the wrong place will cause an error. Assembly language programs cannot be executed by the CPU, however. The CPU only understands machine language, so a special program known as an assembler is used to translate an assembly language program to a machine language program. High-level languages. Although assembly language makes it unnecessary to write binary machine language instructions, it is not without difficulties. Assembly language is primarily a direct substitute for machine language, and like machine language, it requires that you know a lot about the CPU. Assembly language also requires that you write a large number of instructions for even the simplest program. Because assembly language is so close in nature to machine language, it is referred to as a low-level language. In the 1950s, a new generation of programming languages known as high-level languages began to appear. A high-level language allows you to create powerful and complex programs without knowing how the CPU works, and without writing large numbers of low-level instructions. In addition, most high-level languages use words that are easy to understand. For example, if a programmer were using COBOL, which was one of the early high-level languages created in the 1950s, he or she would write the following instruction to display the message "Hello World" on the computer screen. Display "Hello World." Python is a modern, high-level programming language that we will use in this book. In Python you would display the message "Hello World" with the following instruction. Print "Hello World." Doing the same thing in assembly language would require several instructions, and an intimate knowledge of how the CPU interacts with the computer's output device. As you can see from this example, high-level languages allow programmers to concentrate on the tasks they want to perform with their programs rather than the details of how the CPU will execute those programs. Since the 1950s, thousands of high-level languages have been created. Compilers and interpreters. Because the CPU understands only machine language instructions, programs that are written in a high-level language must be translated into machine language. Depending on the language that a program has been written in, the programmer will use either a compiler or an interpreter to make the translation. A compiler is a program that translates a high-level language program into a separate machine language program. The machine language program can then be executed any time it is needed. The Python language uses an interpreter, which is a program that both translates and executes the instructions in a high-level language program. As the interpreter reads each individual instruction in the program, it converts it to machine language instructions and then immediately executes them. This process repeats for every instruction in the program. Programming languages. Language description. Ada was created in the 1970s, primarily for applications used by the U.S. Department of Defense. The language is named in honor of Countess Ada Lovelace, an influential and historic figure in the field of computing. BASIC, Beginner's All-Purpose Symbolic Instruction Code is a general-purpose language that was originally designed in the early 1960s to be simple enough for beginners to learn. Today, there are many different versions of BASIC. Fortran, Formula Translator, was the first high-level programming language. It was designed in the 1950s for performing complex mathematical calculations. COBOL, Common Business-Oriented Language, was created in the 1950s, and was designed for business applications. Pascal was created in 1970, and was originally designed for teaching programming. The language was named in honor of the mathematician, physicist, and philosopher Blaise Pascal. Language description. C and C++, C and C++, pronounced C++, are powerful, general-purpose languages. Developed at Bell Laboratories. The C language was created in 1972. And the C++ language was created in 1983. C#, pronounced C#. This language was created by Microsoft around the year 2000 for developing applications based on the Microsoft .NET platform. Java was created by Sun Microsystems in the early 1990s. It can be used to develop programs that run on a single computer or over the internet from a web server. JavaScript, created in the 1990s, can be used in web pages. Despite its name, JavaScript is not related to Java. Python, the language we use in this book, is a general-purpose language created in the early 1990s. It has become popular in business and academic applications. Ruby is a general-purpose language that was created in the 1990s. It is increasingly becoming a popular language for programs that run on web servers. Visual Basic, commonly known as VB, is a Microsoft programming language and software development environment that allows programmers to create Windows-based applications quickly. VB was originally created in the early 1990s. Keywords, operators, and syntax, an overview. Each high-level language has its own set of predefined words that the programmer must use to write a program. The words that make up a high-level programming language are known as keywords or reserved words. Each keyword has a specific meaning, and cannot be used for any other purpose. The Python keywords. And del from not while. As elif global or with. Assert else if pass yield. Break except import print. Class exec in raise. Continue finally is return. Def for lambda try.